Compound M has a molecular formula of C5H10O, and it decolorizes bromine in carbon tetrachloride. Now, here is the first clue for us to identify compound M. So, what kind of compounds decolorizes bromine in carbon tetrachloride? Something that is going to have unsaturation. So, this is going to have some unsaturation. Let's first find the degree of unsaturation on this. Okay. C5H10O. So, let's apply the formula 2C plus 2 plus hydrogen minus X divided by 2. So, that's going to be equivalent to, there are 10 hydrogens and there is no halogens, divided by 2. That's going to be 10 plus 2 minus 10 by 2. The degree of unsaturation is going to be 1, which means that it could be either a double bond or it could be a ring structure. Now let's go on to the next part. So this compound, when it is reacted with hydrogen in the presence of nickel catalyst, is converted into compound N, which has the molecular formula C5H10O. So if this undergoes hydrogenation, so C5H10O, if it undergoes hydrogenation, it gives us C5H12O. So basically the hydrogens are getting added to this compound, right? So if there is going to be a ring structure, we can't add any hydrogen. If there is only just ring structures, we can't add any hydrogens to it. The only possibility is this is going to have a carbon-carbon double bond. So this is the one that's responsible for this degree of unsaturation of 1. Okay. Now let's go to identify the rest of the things that we have here. So here is the NMR spectrum of this compound, and this is the C13 NMR details. Let's now take a look into the HNMR spectrum and identify the different types of hydrogens present in this compound to get the structural formula of the compound. Okay, so the very first peak is present at about 1.2 ppm and it corresponds to 6 hydrogens. This can be easily taken for 2 methyl groups. And the fact that this is a singlet is going to tell us that these methyl groups are connected to a carbon which doesn't have any hydrogens. Okay. So this should be the fragment for this. Okay, and then these 2 groups should not be hydrogen. It should be connected to something else. And on the left side, we see another peak that is again a singlet that corresponds to 1 hydrogen. And this could be for an OH peak. Normally the OH peak is going to be like slightly broad. And this we can take it for hydroxy group. Okay. And then when you come in the far downfield region, we can see that there are 3 hydrogens and there are 2 doublets. So we have 2 doublets and there is a doublet of a doublet. This one right here is a doublet of a doublet. Okay, and all of these should be vinyl protons because vinyl protons are the ones that's going to come in this region. And this is going to have this structure. Okay. So for example, and this is definitely connected to something else. For example, this hydrogen right here should be split as a doublet of a doublet by both of these protons, right? So this hydrogen is going to give this signal. Okay, it's going to give us doublet of a doublet. So this one right here, let me label this as A. Okay, so this is going to be for the HA protons. Now these 2 protons should be exhibiting their own signals, which can be seen here. I'll label this as B and C. C, so this is going to be HB and HC. Now let's match the number of carbons and hydrogens that we have, hydrogens and oxygens in this compound. Okay. Now on here we do have 1, 2 carbons, and then here we have 3 carbons. That totally counts to 5 carbons, and that's what we have here. Then when it comes to hydrogens, we have 1, 2, 3, 3 plus 6, 9. And then we also said that this is going to be for OH, right? This is the OH peak. So that's going to be the 10th hydrogen. So we do have. So probably like these are all the different fragments of the structure. Now let's put all these things together. This has to be connected with both of these. Now if we put all of this together, This is the formula that we'll be getting. This should be the structure of compound M. Let's go back to our second part of the question. When compound M, which is this, when it is reacted, when it is hydrogenated, it's going to give us compound N, which has this formula. So when we reacted with hydrogen, what happens is the hydrogen is going to get added across the double bond, which we call as electrophilic addition reaction, right? So you will be having two hydrogens getting added across the double bond. So this should be compound N, and this should be compound N. This one has a molecular formula of C5H10O, and this one has a molecular formula of C5H12O. And one last thing that we can do is we can also find the number of carbon signals here. So there are totally 4 carbon signals that compound M is showing. So from the structure, we can clearly see there are 4 different carbons. Okay, so this is A, B, C, and then these 2 methyl carbons are going to be one and the same.